Section 14.7, more on graphing quadratic functions and applications. The objective, graph quadratic functions of the form y equals ax squared plus bx plus c. Example 1, find the line of symmetry, the vertex, the x-intercepts, which are your zeros, and y-intercept for the function y equals x squared minus 10x plus 21, then graph the function. So our function is y equals x squared minus 10x plus 21. And for this problem, we're going to use completing the square as our method for solving it. So when we complete the square, we have to add the same quantity to both sides, which in this case, it's going to look a little bit different. But if we were to complete the square, we would want to take 1/2 times negative 10, which would give us negative 5, and then negative 5 squared would be 25. So you'll notice here, because I want to keep everything on one side of the equal sign, I'm adding and subtracting that 25, because that gives me a net result of 0. In this next step, I'm just grouping the problem a little bit differently. So I'm putting the x squared minus 10x plus 25 together in a grouping and bringing that negative 25 out so that I have negative 25 plus 21. And then what I have inside of my parentheses here ends up being a perfect square trinomial that I can factor. So that factors into x minus 5, the quantity squared, and then negative 25 plus 21 is negative 4. And remember again, this is your factor. Now that equation is in vertex form. In this form, we see that the line of symmetry is x equals 5, and the vertex is at 5, negative 4. By setting y equal to 0, we can find the x-intercepts, or zeros, of the function by solving for x. So I have x minus 5, the quantity squared, minus 4 equals 0. I'm going to add 4 to both sides. That leaves me with x minus 5, the quantity squared, equal 4. I'm going to take the square root of both sides, which leaves me with x minus 5 equals plus or minus the square root of 4. In this step, I'm adding 5 to both sides and simplifying the square root of 4, which leaves me with x equals 5 plus or minus 2. That's two different solutions. This gives me x equals 7 or x equals 3, and the zeros or x-intercepts are at 7, 0, and 3, 0. To find the y-intercept, we substitute x equals 0 in the function. Y equals 0 squared minus 10 times 0 plus 21, which when I simplify that is equal to 21. The y-intercept is at 0, 21. The figure in the following slide is going to show the graph with the vertex, the line of symmetry, and the x-intercepts labeled. Note that the y-intercept lies outside of the given grid, so we won't see it. So here is our graph. So our line of symmetry is this red dashed line at x equals 5. Our vertex is down here at 5, negative 4. Our x-intercepts are at 3, 0, and 7, 0. And we'll just review that our y-intercept was 0, 21, but that would be way up here, so we're not going to see that in this particular problem. Example 2, find the vertex, the line of symmetry, the x-intercepts, and y-intercept for the function y equals negative 3x squared minus 12x minus 9. Then graph the function. So once again, our function is y equals negative 3x squared minus 12x minus 9. And we're going to start by factoring a negative 3 from those first two terms, because I'm going to use the completing the square method again. That leaves me with y equals negative 3 times x squared plus 4x, that quantity, minus 9. Now I'm trying to complete the square by taking half of 4, which is 2, and squaring that, which is 4. So notice the negative 3 is still out here. I'm doing plus 4 minus 4, so I have a net result of 0. So we've got y equals negative 3 times the quantity x squared plus 4x plus 4 minus 4, and then subtracting 9. Once again, I'm going to regroup this a little bit. So I have y equals negative 3 times the quantity x squared plus 4x plus 4. And then notice when I pulled this negative 4 out, it became a 12. And the reason is because this negative 3 is here. When I have, the number I really have here is negative 3 times negative 4, which is a positive 12. So that comes out as positive 12 minus 9. This leaves me with y equals negative 3 times the quantity x plus 2 squared plus 3. Again, remember this is your factor. So this is in vertex form. Now this negative coefficient in front of here, this negative number, means this my parabola is going to open down, just for information's sake. And then my vertex is going to be negative 2, 3. So you'll see that here. We see that x is negative 2, which is our line of symmetry, and the vertex is negative 2, 3. We're going to set y equal to 0 to find our x-intercepts. So negative 3 times the quantity x plus 2 squared plus 3 equals 0. I'm going to start by subtracting 3 from both sides. So negative 3 times the quantity x plus 2 squared equals negative 3. Now I'm going to divide both sides by negative 3. So x plus 2, the quantity squared, is equal to 1. Now I have my squared term isolated, so I can take the square root of both sides. That leaves me with x plus 2 equals plus or minus the square root of 1. So x is equal to negative 2 plus or minus 1. So I subtracted 2 and evaluated the square root of 1 there. This gives x equals negative 1 or x equals negative 3. So our x-intercepts are negative 3, 0 and negative 1, 0. To find our y-intercept, we're substituting x equals 0 into the function. Y equals negative 3 times 0 squared minus 12 times 0 minus 9 ends up with y equaling negative 9. My y-intercept then is 0, negative 9. And again, we're going to have a figure on the next screen that's going to show all of this information to us, the vertex, the line of symmetry, and all of the intercepts labeled. So this is our graph, and remember I said since had a negative 3 at the beginning, it opened downward. Our line of symmetry is this red dashed line at x equals negative 2. Our vertex is up here at negative 2, 3. Our x-intercepts are at negative 3, 0 and negative 1, 0. And our y-intercept is down here at 0, negative 9. Example 3. For y equals negative x squared minus 4x plus 2, find the line of symmetry, vertex, x-intercepts, and y-intercepts. In this problem, we're going to use a slightly different method, and this can be found in your formula sheet for this course. For y equals negative x squared minus 4x plus 2, we have a equals negative 1, b equals negative 4, and c equals 2. If x is the opposite of b over 2a, which is your line of symmetry, and it's also the x-coordinate for your vertex, in this case that would be equal to negative of negative 4 over 2 times negative 1, which when it simplifies down is negative 2. Then we can figure out, again, this negative 2 is going to be our axis of symmetry equation line. It's also going to be the x-coordinate for our vertex. So we're going to take that number and plug it in to figure out what our y-coordinate is for our vertex. So we have the opposite of negative 2 squared minus 4 times negative 2 plus 2. It's going to give me negative 4 plus 8 plus 2, which is 6. So the vertex is negative 2, 6, and the line of symmetry is x equals negative 2. If we plug 0 in for x, then we'll figure out what our y-intercept is. So in this case, y equals negative 0 squared minus 4 times 0 plus 2, which means our y-intercept is 0, 2. If we plug y equal to 0 in, then we can figure out what our x-intercepts are. So we have negative x squared minus 4x plus 2 equals 0. Using the quadratic formula, x equals 4 plus or minus the square root of negative 4 squared minus 4 times negative 1 times 2 all over 2 times negative 1, which equals 4 plus or minus the square root of 24 over negative 2, which is equal to 4 plus or minus 2 square root of 6 over negative 2, which is equal to negative 2 plus or minus the square root of 6. So our x-intercepts are at negative 2 plus the square root of 6, 0, and negative 2 minus the square root of 6, 0. Again, we have a graph here, and so our line of symmetry is this red dashed line at x equals negative 2. Our vertex is up here at negative 2, 6. Our x-intercepts are at negative 2 plus the square root of 6, 0, which is actually on this side, and negative 2 minus square root of 6, 0, which is on this side. And our y-intercept is here at 0, 2. Example 4, for y equals 2x squared minus 6x plus 5, find the line of symmetry, vertex, x-intercepts, and y-intercept. Once again, we're going to use that x equals the opposite of b over 2a to find our axis of symmetry, line of symmetry, and to find the x-coordinate for our vertex. So for y equals 2x squared minus 6x plus 5, we have a equals 2, b equals negative 6, and c equals 5. If x is equal to the opposite of b over 2a, that's equal to the opposite of a negative 6 over 2 times 2, which ends up equaling 3 over 2. So then when I plug in 3 over 2 for x, I end up with y equals 2 times 3 over 2 squared minus 6 times 3 over 2 plus 5, which ends up being 9 over 2 minus 9 plus 5, which ends up being 1/2. So my vertex is 3/2, 1/2. My line of symmetry is x equals 3/2. Notice your line of symmetry and your x-coordinate for your vertex are the same value. If I plug x equals 0 in, I can figure out what my y-intercept is. So in this case, y equals 2 times 0 squared minus 6 times 0 plus 5, which means our y-intercept is 5. So our coordinate is 0, 5. If I let y equal 0, then 2x squared minus 6x plus 5 equals 0. Using the quadratic formula, that gives me x equals 6 plus or minus the square root of negative 6 squared minus 4 times 2 times 5 all over 2 times 2, which is 6 plus or minus the square root of negative 4 over 4, which is x equal 3 over 2 plus or minus 1/2 I. Here we have non-real zeros because the discriminant is negative, so the graph is actually not going to cross the x-axis, so you don't see where those x-intercepts are. So our summary here, we have our vertex at 3/2, 1/2. Our line of symmetry is at x equals 3/2. Our x-intercepts, we don't have any real x-intercepts to graph, so again, we don't have any to graph here. So there's no x-intercepts. There are still zeros, but there are no x-intercepts. And our y-intercept is 0, 5.